Let's see what is sp2 hybridization and how it happen and what are the properties of sp2 hybridization. So in again, if you see the electronic configuration of the carbon, as I showed, like in excited state, the 2s paired electron goes to the 2p0 to form like unpaired electron. Now in that case, when one s orbital and two of the p orbital mix together, same as I explained for the sp3, so here like just one s2p, so in that case we can say sp2 hybridization. So suppose you got a big amount, so now just think how many orbital mixed here, 1 2 3, so you will get new different kind of same energy, same property, new three orbital, mixed orbital. That's why it is called hybridization. So mixed orbital, and each of these orbital has one electron. So you can say it has one electron, one electron, one electron each. So, and they are called sp2, sp2, and sp2. And in that case, what is the s character of this sp2? So you can think 33% of s and p will be like 66 point something percent. So if you take like 100% of sp2, like 3 among 3, 1 is s, like, so among 100 how much s? So same, like 33% s and remaining like 66% p, 33 point something percent s and 66 point something percent is p. So s character and p character, you know that, like from the sp3 to sp2, the s character is increasing. It is an important point. It has a property, like if s character increase, then there is something we need to know. I will discuss later. So once this sp2 hybridization hybridized orbital formed, then you can think of how it formed the molecule. Let's see. So in case of carbon, so since it has a 3 sp2 hybridized orbitals, so you can say like this. And another carbon with these three. So we can show, suppose the hybridized orbital is like this, like mixed orbital. So we can draw like that. So here 2 electron, one from each overlap. So that is called sigma bond. That is called sigma bond. Now when one hydrogen come here with another electron, so they have one electron from here and hydrogen here, and same thing here, one hydrogen, so one electron here, and from here another electron. So this form one sigma bond, another sigma bond. So here you can say this is sp2s, because hydrogen is s orbital, sp2s sigma bond. Here also we can say sp2 sigma bond, and this is, you can say sp2 sigma bond, this part. And same as these two hybridized orbital also will mix overlap with the hydrogen, one electron from here, one electron from hydrogen, and from here, so one electron from this orbital, one electron from hydrogen, so it form new sigma bond. So we can say this is sp2s sigma bond, and this is also sp2s sigma bond. So remember, we mixed the carbon like 2p orbital and one s orbital, but still it has one p orbital unhybridized, like not mixed. So we can put here as like unhybridized orbital. So this one also unhybridized orbital. So this unhybridized orbital also have the electron, one electron each, if you remember, like 2pz1. So then they can produce partial overlap, that is called partial overlap. So this will form a partial overlap, and this like this. So we can say this is partial overlap, and this partial overlap create a new bond, including both of them. So both of them is like one bond, that is called pi bond. So we can say this is a pi bond. So one sigma bond, one pi bond. So in case of sp2 hybridization, it forms carbon-carbon one sigma bond and carbon-carbon one pi bond. So that means you can think carbon-carbon sigma bond. So this is hydrogen, this is hydrogen, and this is hydrogen, this is hydrogen. So one is sigma bond, another is pi bond. Okay. So in that case, remember this carbon-carbon double bond, it is planar shape. So it is in the plane, like so. Here you can see this molecule. So this double bond, one is sigma bond, another is pi bond. So if you think like this, so it is you can put in a plane of the paper or like something, so planar, and two hydrogen is toward two different part. So this is actually sp2 hybridized ethene molecule. So carbon-carbon double bond, these two, like one sigma bond, one pi bond, and this is like you can think this bond is sp2s sigma, sp2s sigma, sp2s sigma, and sp2s sigma. But here you can say one is sigma, so sp2 sigma and sp2 pi. And remember one thing, one pi bond, since it has a one pi bond, so always if one pi bond break down, so it will produce new two sigma bond. So one pi bond always break to two new sigma bond. So this is the real story about the sp2 hybridized molecule. And another important thing is each hybridized orbital, in between each hybridized orbital, the angle is 120 degree. 120 degrees. So like this and this, so 120 degree, and this is 120 degree, and this is 120 degree. So if you take the model here, so here from here to here the angle is 120, from here to here angle is 120, from here to there angle is 120. So 120, 120 and 120 degree. So this is the sp2 hybridization.